Well, now that we know what rectangular coordinate plane is and how to plot points, let's work through some contextualized problems. So this table is representing a small plane taking off from an airport, and it's got its flight time as x values and its altitude as y values. So on our provided graph here, we've got the x-axis labeled as the flight times, noting that the units of these 10, 20, 30, 40, 50 thing is minutes, and then the altitude is in feet. Notice the scale going on. We've got a 0 here at the start, awesome, and then 10, 20, 30, 40, 50, 60, 70 minutes, and then steps of 1,000 for altitude. So our author asks us to write all of these values as ordered pairs. A little bit tedious to the mathematician or the math-minded person. You're going to look at this table and see ordered pairs instantly. So why bother writing them? And if you're not a math-minded person, don't worry. By the end of this unit, I suspect you'll feel the same way. I hope you will. Okay, so here I've listed them all. I almost thought I made a mistake. I feel like there's too many commas. Just as a heads up, Desmos does not like commas with the numbers, so Desmos wants you to write it as 50, 1000 without the commas in there. Commas are just to help us read the number. So there's my ordered pairs, and then I'm going to plot them here. 0, 0, 10, 4000, 20, 3000, 30, 2000, 40, 2000, 50, 1, almost a mistake, 1060, 0. Now, our author tells us to connect these points. I disagree with that because when we connect points, we're suggesting that there's some sort of equation that would generate the connection of these points. And, well, you know what, we could do it. It's just, it would be a really complicated equation to write out. So I think it's better to not connect them, but I will do it. And the reason is it helps us see the shape. So, our author tells us to add a verbal label to each axis. Check, that's done. This is what he's asking us to do, and it's important to keep track of that. All right, so now we're going to answer a whole series of questions about this graph. The first one is, what was the highest altitude reached by the plane? Well, if you look at the numbers, we're picking out the largest number. That's 4,000 feet. If we're looking at the graph, we would be looking at the highest point on the graph. Are these different? Oh, no, but maybe our explanation is different. So from table, we found the largest number. From the graph, we looked for the highest point. And for folks that are big-time math people that do this a lot, I'm talking about myself here. I don't know that I'm big time, but I'm constantly engaged in mathematics. I'm paid to do this, right? There is no difference to me based on what I see in this picture and what I see in the table. And our author, I believe, is trying to make that connection for you, that the graph is just a visual representation of the numbers. And when you deal with numbers a lot and graphs a lot, you make that connection instantaneously. And sometimes you prefer to work with the table, depending on what you do. Sometimes you prefer to work with the graph. It's often nice to have both. All right. Here we have, how long after the flight began did the plane reach its highest altitude? Well, there we're looking at the time, the x-axis. It took 10 minutes. Do we have slightly different answers? No, I mean, maybe how we're explaining what we did. We're noting the x value when y was largest, or the x value for the highest point. So I'll say x value when the y value was largest. Versus in terms of the graph, we're seeing this x value at the highest point. So technically, those are different words, different descriptions. One's a visual, the other is a numerical. But as I'm hoping to drive home here, they are the same thing. So when was the plane flying level? Well, notice the word when tells us that we're talking about flight time. So we're to report an x value, and it is from 30 minutes to 40 minutes. Between that time, it is not ascending, so it's not going up or going down. It's just keeping the same height for 10 minutes. And then how long did this flight last? Well, it started at 0 minutes at 0 altitude, ended at 0 altitude. Hopefully you would connect the dots that when the plane has 0 altitude, it's no longer in the air. So the flight has landed. That was a 60-minute flight time. And then we're asked, hey, when is this thing increasing? When is the altitude increasing? This is connecting to slope. So we're looking at where are the y values increasing? So we've got that only from 0 to 10 minutes, only that interval. If you want to get really mathy, check out this cool thing. This is how the math folk write it. You're not going to be expected to do this in this course. This is called interval notation. I'm just giving you like a little bonus here. Maybe you're interested in taking some college algebra. You would see this in college algebra. I'm forgetting how to spell notation all of a sudden. That feels okay. This little wonky E is a logic symbol, and it means belongs to. All right, a couple more questions about this graph, and then we'll move on to something else. We're next asked, when is the altitude decreasing? Altitude of the plane. Again, notice the word when is asking for time, so we're looking for x values. Well, this happens from 10 to 30 minutes. Then the plane levels out, so it's no longer decreasing. And then it's decreasing from 40 to 60 minutes. Those of you that love that interval notation, it's x values belonging to 10 to 30. Union, which is a fancy way in the math world to say and, 40 to 60. Again, don't stress about this. Mostly, you need to understand how to read that time interval. Okay, last question is a little silly, but also really important to connect. Oftentimes we forget that mathematics is applied to the real world. In fact, the development or discovery of mathematics happened because folks observed the real world, not because they played games in their head like mathematicians like to do. So why didn't we bother to include negative values? Well, we have to ask ourselves, what would negative x values mean? So negative x would correspond to negative time. That doesn't exist in the real world. You can't go backwards in time. However, we could think it as time before the plane took off. And we know exactly what that's going to be, right? The plane's just sitting on the ground. So it would be 0 altitude forever and ever and ever until the plane took off, unless there was a previous flight it went on. You can see we can quickly go down the rabbit hole of creating useful information here that really isn't useful. We're only interested in this one flight that was taken. All right, what's up with the negative y values? So negative y means negative altitude. All right, that doesn't exist. Of course, altitude is the distance from the Earth's surface to wherever you are in the air. And in the three-dimensional world, boy, that gets wild. If you could get out in space and get on opposite sides of the globe, you could then think about negative. So say you were flying here. Here's my awesome plane. And then you got around to the other side of the Earth, and you are now flying over here. These would be negative altitudes compared to your starting point here. But that's getting crazy, right? Like, that's not super helpful. And mostly when we experience the world, we experience a flat plane. We don't experience a sphere because of how limited our view is of the Earth.